exercise 6E is the last exercise of chapter 6. Chapter 6 only had a couple of skills. So A and B was ratios. You just had to learn to simplify and then learn to use it to solve a problem, which is 6B. So if you're running short on time, focus on 6B and then do 6E. You can almost skip 6A. Okay? If you're running really far behind. If you're really far behind, do 6B and 6E. And that should be enough. So, what is 6E about? I've got only 3 examples. The main example is actually the one in the back. The one that you should train is the second one. The first one everyone should be able to do because it's simplifying. So here we go. Example 1. Joanne can type 80 words per minute. So we write it in. We say 80 words per, which usually we use that / minute. This is called a rate. Often rates have units, whereas ratios do not have units. You could say it's like 80 to 1, but this one's more clear because we know what the units represent or what the numbers represent. Then we say, well, how many words can she type in 25 minutes? So we do a comparison. We say, all right, this is for every 1 minute. So for 25 minutes, this is clearly 25 times more than 1 because I need 25 of them, right? So 25 times more. So how would I work it out? Logically, you would then figure out whatever you do to one side. If you times 1 by 25 to get to 25, what do you have to do on the left? Times by 25. So that is all you had to do for the first one. So it's the idea of learning how to use a simplest rate to then convert to the problems you need. Okay? Now the question is, what is 25 times 80? And sometimes when I say that, students get confused, so I break it up for them. I say, all right, 25 times 80, we don't know, but we can break up the 80 to 8 times 10. And then when I say, what's 25 times 8? Some students may know, and some students still don't know, so then I do this. Break the 8 into 4 times 2. So we break it all apart. This one's easy. What's 25 times 4? 100. So if you times it by 2 now, 200. Oh, well, 200 times 10 is then 2,000. So when I say what's 25 times 80, it may have felt really hard to do. But if you break the numbers apart, find the numbers that you're familiar with, that is another way to quickly do mental arithmetic. Okay, otherwise you can do the long multiplication. But the answer for this one, yes, it would then be a total of 25 times 4 is 100, 100 times 2 is 200, and then 200 times 10 is 2,000. So the answer is, assuming that Joanne does not get tired after 25 minutes of consistent typing, doesn't go faster or doesn't go slower.
Maybe she's writing a book.
Yes. Then she's in the zone, then maybe she will hit around 2,000 words. Okay? Let's go into example 2 now. So example 1 is a straightforward using a simple rate to then solve a problem. What if now you don't have a simple rate? Here's example 2. A hot dog vendor sells on average 60 hot dogs every 20 minutes. On average. Okay, so on average, every 20 minutes, they're selling about 60 hot dogs. So the rate is 60 hot dogs per 20 minutes. That's pretty good.
Very good.
Yeah, it is very good. Yes. So the question is, because he's so successful, or he or she, or the vendor is thinking, I want to sell 210, but I wonder how long I'd have to actually be there to sell 210. So if I want 210 hot dogs, the question is, how many minutes? Or how long will this take? Okay, well, let's try to work this out. So 20 minutes. If I double it to 40, 20 to go to 40 just means you double it. But that means if you double the hot dogs, the rate would be 120. It's not 210. So there's a problem here. See, unlike before, if you had it in simplest form, you can then work towards figuring out how long it is. But the problem is that it's not the per minutes that you needed. It's actually per hot dog that you needed. So that's another way of doing it. So in my example, I got you to try to figure out, well, how long does it take just to sell, on average, 1 hot dog? Okay? So the logic here is that how do I go from 60 to 1? Divide by 60. 60 divided by 60 gives me 1 hot dog, but whatever you do to the left, you do to the right. So this now brings me to 20 divided by 60. 20 divided by 60 is the same thing as writing 20 over 60. But simplify that fraction for me. What's 20 over 60 the same as? 1 over 3, very good, because 20 goes into 20 once and 20 goes in 60 3 times. So it's a third of a minute. So a third of a minute is how long it takes to sell 1 hot dog on average. So here I wrote 1 hot dog per third of a minute, or third minutes. So now that you know that's how long it takes to sell 1 hot dog, then to get 210, let's go backwards now. How do I go from 1 to 210? Times by 210. But that also means I can then times the 1/3 by 210 to figure out how long that would take. So here we go. The mathematics would then be, what is 210? 210 times 1/3. Using your fraction skills, 210 as a fraction is 210 over 1. Very good. We can simplify these two numbers, or essentially it's 210 over 3. How many 3's fit in 210? Yeah, so we can see 3 can't go into 2, but 3 can go into 21. 7 times, and then 0. So that must be 70 minutes. So the answer here now must then be 70 minutes. Okay. So it will take 70 minutes to sell on average 210 hot dogs is how long this hot dog vendor would have to sell it for. That was one way of doing it. The other class actually used a different method, which could be faster and it may be easier if you didn't prefer going through 1/3. So what's another way of doing it? Well, this is another way of doing it. You see, the 60 is a problem. 60 doesn't go into 210 well, but you can change that number so that it fits into 210 well. So this is what the other class did. They went, I'm just going to write it down here to make a new one. So you started off with 60 hot dogs per 20 minutes. So what the other class did was they did, well, if I halve it, it's 30 hot dogs for every 10 minutes. Does that make sense so far? So if I just halved it, divided by 2, divide by 2. But then what they said was 30 will fit nicely into 210. So if you want 210 hot dogs, how many 30s would make 210? 7. 30 times 7. Yeah, 30 times 7 will give you 210. So what they did was they just said 10 times 7, 70 minutes. So this is, it is technically the same method. It's just that the numbers work out nicer. So that's why I'm saying that you don't always have to do it the way I'm teaching you, but you can be flexible and creative with the rates. That's the whole point of rates. Rates you can change as long as the ratios are the same. Yeah, so in each one I just did divide 60 times 210 times 210. They did the same method, but they just found a number that worked better for them. So they were more creative in that sense to go 60 down to 30 and then 30 to 210. Sometimes you can't find a number, then my method works better. But if you can be creative and find a number that works better, this would be a lot faster. Okay, so copy down those two different ways of getting the same answer, and then so that when you see a problem, see if you can find that sort of easier method. That's called problem solving. That there, where you see an example 2, is the skill that I want you to take out from 6E. Okay? Your final example for today is the one on the back. Now this one, I'm going to teach you how to do it. I don't expect everyone to know how to do it. Okay, you guys can actually do it intuitively, but for some reason when I do it in the test, most students leave it blank. Okay, so here's the intuitive one. So flip over. Example 3. So on the back. So students usually get something like this. This is called a work rate problem. And usually it comes with like painters and like say they might say a painter It takes 2 hours to paint a room. If I had 5 painters, how long does it take? Something like that, right? So in this case here, I've got a swimming pool. So I'm going to draw the scenario. I've got a swimming pool, but I've got 2 hoses. Hose 1, yes. Hose 1 will take 100 hours to fill it up. So hose 1 takes 100 hours to fill it up alone, whereas hose 2 will take 150 hours alone. And that's what the question's asking. So the question's asking, well, what if I want to make it faster? Because one goes for 100 and the other one takes 150 hours. Then what if I put them both together? So how long would it take to fill the pool with both of these hoses? Now my guidance, I've got the notes to help remind you on how to solve this problem. But that's usually the bit that a lot of students give up. So once they read that, they're like, I have no idea how to start. So they give up. So I'm going to show you how to do it. Here's the logic. We know that the rate for the first hose was it takes 100 hours per pool. Or another way of thinking about it is for every one pool, it takes 100 hours. True? So going with the first rate, let's fill out the table. Hose number 1. One pool, how long does it take again? 100 hours. What if I asked you to do 2 pools? 200. So the pattern is 3 pools would be then 300. 4 pools would then be 400. 5 pools would be 500 and then so forth. So 600, etc. Right? What about hose number 2? Hose 2 says it's 150 hours for every pool. So essentially I'm saying for one pool, it takes 150 hours. So if I write down the pattern for the second one, hopefully you start to see something. 150 for one pool. For 2 pools, how long would it take? 300, because you add another 150, so then it becomes 300. Third pool takes 450, add another 150, so it becomes 450. Add another 150 gives you 600, add another 150, 750, and then another 100 gives you 900, etc. But out of the 2, there is a common number that you can see.
600.
Yes, they both have a 600 and 300. So this is key because if you take the whatever's in common, you can do with the 600, you can do 300. I'll do 300 because the numbers are smaller. You're essentially saying this. What we can see is that at 300 hours, which is their common time, together, how many pools would have been filled? See, this hose would have filled 3 pools plus, yes, that's right, this one would have filled 2 pools. So the rate that this is going, if I combine them both, how many pools can I, what's the rate that it can fill up? It's 5 pools per 300 hours. So now this is a nice rate because that's the combined rate. But I could only combine them once I have something that's in common. So here, if you answer the question, 5 pools per 300 hours. If you want to know how long it takes per pool, okay? Actually, what did it ask? It said, how long would it take to fill, one pool. So if I want 1 pool, how do I go from 5 down to 1? Divide by 5. But whatever you do to one side, you do to the other. So 300 hours divided by 5 gives you 60 hours. So now you know the combined rate should take you 60 hours. Now, that is the most intuitive way to answer that type of question. So my guided notes is to help remind you if you happen to see those kind of problems. But actually, the easiest way to do this problem was actually fractions. For those who actually want to know the shorter way to do it, it literally was just 1 pool for the hose was 1 per 100 hours. You could actually write that as a fraction as 1 over 100. The other one was 1 pool per 150 hours. So you can write that as 1 over 150. But you see, when you add these fractions, you're essentially adding this rate plus that rate. But we know the thing with fractions is you can't add the rates because they have different denominators. Yes, you make it the same denominator. So in this case, find LCMs, times this by 3, times this by 3, times this by 2, times this by 2. And that's how you get 3 over 300 plus 2 over 300. Now they have the same denominator, which means they have the same rate. 5 over 300. Simplify that fraction. 1 over 60. And this means 1 pull per 60 hours. But it just means that you have to remember the numerator represented pulls and the bottom represented hours. So that's a quicker way to solve the problem. But when I put that in a test, often students have forgotten or don't remember how to solve this problem. So that's why I had a guided one, which is intuition. And that would be how you would solve it. And theoretically, why you would do it that way. Okay? But that's an extension question. So I gave you 3 types. I gave you a simple one on what you do with a basic rate. I gave you example 2, which is a typical one, but you can be creative. And the third one's an extension. So find where you are in exercise 6E and practice that. But that's only to get you ready for next week's mastery task. Okay? Main thing is fractions, decimals, percentages. You have to practice that. This one's going to be a small part of it. Okay, so I won't be putting too much rates and ratios, but I do want to know that your fractions, decimals, percentages are good. Okay, so make sure all that homework is updated and uploaded before Thursday next week so that I can do a all-nighter crash on reports to write as much as I can before the end of term. Thanks, team. I'm going to stop the video there.